Welcome back. This is lesson 3.1. This is our first lesson in the second chapter of my 8th grade curriculum, and this one deals with proportional relationships, something we talked about in 7th grade, but it's good to review again because our second chapter is going to deal with slope, y-intercept, linear equations, and proportional relationships are like the base of linear equations, or the most basic version of a linear equation. First thing we talk about is what exactly is a proportional relationship. A proportional relationship is one where the rate of change is constant, or the ratio of one quantity to another quantity is the same. A proportion is a statement that two amounts are equal. Basically what that's saying is you have two things happening and they're both increasing by the same amount. For example, if you're at a job and you make $15 per hour, because that's the example we have over here, that means that every time my hour increases, that's one of my variables, or one of my amounts, my quantities, the amount of money I have goes up by $15. And every single hour, when I work another hour, I get another $15. That's constant. It never changes. So that's an example of a proportional relationship. Every time one thing goes up, another amount goes up by the same constant ratio. So we have 1 hour, we make $15, 2 hours, we make $30, 3 hours, we make $45. We always have equivalent fractions no matter what. 1/15, or 15 over 1 and 30 over 2 are both the same fraction. If we doubled 15 over 1, we would get 30 over 2. So we're looking for something where we have the same ratio every time, no matter what. That tells me it's proportional. So that sounds great, but how exactly do I write equations, or how do I even figure out what the equation is for a proportional relationship? Well, like I said in the last slide, since anytime we simplify our fractions or our ratios, we should have the same amount. In the last example, every time I would simplify, no matter how much money I made, no matter how many hours I worked, it would simplify to $15 for every 1 hour. We can actually figure out the constant by placing our y value over our x value and simplifying that amount. That'll give me my constant, which the algebraic representation for that is k. And then we can take that amount and plug it right in to this equation, y equals kx. So it's saying whatever my x value is, I multiply it by k, and it'll tell me what my y value is. So it's saying that constantly we are increasing. That's why it's a constant of proportionality. Y over x in proportional relationships will always be equal. That'll be easier to see when we take a look at our first example. Our first example says the amount of money earned by Brian is shown in the table. Does this represent a proportional relationship? If so, write an equation for this proportional relationship. So almost anytime I'm given a table, my x value will be on top of the table, my y value will be on the bottom of the table, but you can figure it out because my y value is what is called my dependent variable, and it depends on the x. And in this case, the amount of money you earn depends on how many hours you work. So it's an easy way to figure out which one is my y, which one is my x. First thing we need to do is take all of these amounts and write them as fractions. So we have our in the form of y over x. So we have 23 over 1, $23 for 1 hour, 69 over 3, 115 over 5, 161 over 7, 207 over 9. And if I were to divide all of these fractions or simplify all these fractions, I would get the same amount. And that's what tells me that's a proportional relationship. 23 over 1 is just 23. If I did 69 divided by 3, I would also get 23. If I did 115 divided by 5, I would get 23. If I did 161 divided by 7, I would get 23. And if I did 207 divided by 9, I would get 23. Every time I simplify it down, I would get 23 over 1, or just 23. That tells me that this number, 23, is my constant of proportionality. It's my k in the equation y equals kx. So I just take that 23, plug it in the place of k, and I have my equation, y equals 23x. And this means if I want to figure out the amount of money earned, which is my y, I take x, my number of hours, and multiply it by 23. And that will tell me how much money I have. Pause the video, try the next question, then come back to me. Hopefully you tried this one on your own. Every hour, 16 cars are manufactured at the Toyota plant. They want us to create a table and show that the relationship is proportional, then write an equation to show the proportional relationship. Now, it should seem like common sense. Obviously, if every hour 16 cars are manufactured, 16 is going to be my constant of proportionality, but they ask us to show this or prove this. So first thing we need to do is fill out the table. In 1 hour, we have 16 cars. 3 hours, so I do 3 times 16 because every hour is 16 cars. 48. Then I'm going to do 5 times 60, which is 80. 7 times 16, which is 112. And 9 times 16, which is 144. So I've completed my table. I can then do 16 over 1. 16. I can do 48 divided by 3, which is also 16. 80 divided by 5, which is also 16. 112 over 7, or 144 over 9, and every single time I'm going to get 16. This tells me that 16 is my constant of proportionality, and all I have to do is put that into the equation, y equals kx, right in the place of my k, and I get y equals 16x. So figure out your constant, plug that value into your formula, and that'll tell you what your constant is. And all this equation is saying is that every time I want to figure out how many cars there are, which is what my y is, I take the number of hours, which is my x, and multiply it by 16, and that'll tell me the total number of cars that are produced. A couple other things I just want to mention about proportional relationships. Some characteristics that all proportional relationships share, especially in the form of graphs. All their graphs create a straight line, so something that is linear. Linear means straight line. This graph here to the right, it's a straight line. Okay, all of the graphs start at the origin or at 0, 0. Okay, they all increase by the same amount. That is what makes it a straight line. Because if they increase at different amounts, you would see it go up really fast in one spot and kind of level off in another spot. And then just like with our tables, all you have to do is pick any point on the graph, place y over x, and divide, and that'll tell you what your constant k is, and you could write an equation using that constant of proportionality. Let's take a look at an example of that. This question says, the graph shows the proportional relationships between pesos and dollars. Is this graph proportional? If so, write an equation for the proportional relationship. So just by looking at the graph, we have a straight line. It starts at the origin. It increases by the same amount. This is a proportional graph. Okay, they give me some points. These points I can actually use to fill out my table. First point they give me is x is 10, y is about a half. So my x is 10, my pesos are 10, my y is 0.5. This one, my x is 40, my y is 2, so it's 40 and 2. This one, my x is 80, my y is 4. And if I needed another one, there's one right here. I got 105. So I could pick any one of these points. I could put my y value over my x value. So the first one is 0.5 over 10. Or 2 over 40, because remember, this is my x value, this is my y value. It's not always just the larger number in the numerator. It's just the y value on the numerator, the x value in the denominator, then you divide. So I could have 4 over 80, or I could have 5 over 100. They all would simplify to 1/20. So now, there's two ways we could write this equation. We could leave it as a fraction. And we could just say y equals 1 over 20 times x. That means you would multiply the number of pesos you have by 1/20, and that would tell you how much money you have in US dollars. Or I could actually do 1 divided by 20, which we talked about way back in the first section of notes. Put in my decimal point at a 0, It doesn't go into 10, so I have to put a 0 up there, add another 0, and it does go into 100 5 times. And I'm done. So 1/20th is also equal to 0.05. So I could also write it as 1 equals 0.05x. Both of these two equations say the exact same thing. So I want you to try the last problem. I want you to give it to me both in the form of a fraction and in the form of a decimal. Come back to me when you have the answer. So this graph shows the relationship between the amount of time a person hikes and the distance they travel. Okay, I have a bunch of different points here. I can pick any one to figure out my constant, but I'm going to look at one that is right on a line, that is nice and easy to see, where two numbers clearly stand out, and I think this middle one does the trick. And I want to put my y value over my x value. My y value here is 12. My x value is 10. Always want to simplify. This could become 6/5. So I could leave this as y equals 6/5x, or I could drop that numerator in the house and do 6 divided by 5. Okay, which comes to 1.2. So I could also write this equation as y equals 1.2x. Either one of these graphs, or either one of these equations, would be acceptable. So remember, find your constant. If you have a table, you can do it with all your points. Prove that it's proportional by finding your constant for all of them and checking to make sure they're the same. Then you could take that constant, that k, that constant of proportionality, and plug it back into our formula y equals kx. If you have a graph, it's a little easier because you can look at it right away and tell if it's proportional. Does it start at the origin? Is it linear? Does it increase by the same rate the entire time? If it does, you could pick any one of those points, put your y over your x, and figure out your constant that way. If you have any questions, please contact me. Leave a comment, do whatever you have to do.